Hey guys, welcome to another lesson. So today we continue on with the extension 2 topic of vector equations, where the previous lesson, if you sort of watch the video, it's basically introducing questions that deal with, well, vector equations, right? Today, we're going to deal with vector equations and spheres together, right? So before I go on, if you like the video, if you haven't liked the video, please like the video, subscribe to the channel and tell your friends. Let's get started. Now, there really isn't much theory to this, so I'm just going to dive into, I've got a few questions prepared from past papers. Let's dive right into it. So first one's from Helston, 2020. And it's a classic question, right? Find the points of intersection between a vector equation, a straight line vector equation and a sphere, right? Very straightforward, guys. The approach is to basically express the vector equation in terms of its Cartesian breakdown, x, y, and z, and then we solve it simultaneously. And then once you sub it in, you should get a quadratic of some sort that you can solve, right? That's generally the case. So let's get started. So find the point of intersection. So we're going to start with this vector equation here, right? And decompose that, right, into its Cartesian part. So I can see that the x value equals to 1 plus t. I can see that the y values equals to 3 plus 2t. And I can see the z values, right, equals to -4 plus 2t, right? They're the coefficients of I, j, k respectively, right? So once you get that, all you got to do now is plug 1, 2, 3 into this guy. Yeah, I mean, it's 4 marks, right? Now, admittedly, and I keep telling my students this, right? Don't get carried away. Whenever you do a 2020 paper and it's worth 4 marks, it's because that was the first year of the new syllabus, first year that these types of questions arose. So a lot of teachers gave more marks because it was new. Nowadays, this is probably like a 2 marker, maybe 3 if you're lucky, right? So don't get too excited just because it's like a 4 marker here. So let's sub it in. So I want the x value into there, y value into the z. So I want 1 plus t minus 1 squared plus 3 plus 2t minus 3 squared plus z plus, minus 4 plus, this cancelling out really nicely. Yeah, it is. Okay, this question was super easy for 4 marks, Jesus. Yeah, plus 4 squared equals to 81. Because I can see all the numbers cancel out, right? That's just t squared. Plus that's like 2t squared was 4 t squared. That's the same thing, 4t squared equals to 81. 9t squared equals to 81. T, what's it, plus minus 3. Yeah, once you get plus minus 3, right, you can sub the t values back in and you should get 2 sets of coordinates. Because if you think about it, right, if I was a sphere and I was a line sort of breaching it, I should have 2 points of intersection, right? Yeah, that makes sense. So once you sub t in, when t equals to 3, right, the x coordinate is 4, y is, actually, let's just write it as coordinates, right? So let's go 4, 3, what's that? 9, 3, 6 minus, is it positive 2? Check that, right? When t equals to minus 3, minus 2 for x, minus 3, and minus 10, I believe. Check that, perfect. Yeah, that's my answer. That's the points of intersection. How's that, right? Pretty straightforward. So whenever they give you a vector equation and they're asking for points of intersection, right? Generally there are 2, in which case all you got to do is make x, y, z, find the expression of x, y, z, and then sub it in so you can solve a quadratic. In this case, the quadratic, it's not even quadratic, right? T squared equals 9, right? Pretty straightforward. So another one. So this one's from St. George Girls. So 2022, okay, things have matured a bit. So the sphere given to you has a center of that. So I can express the sphere as an equation, right? 6 units. In fact, that's what question 1 is telling you to do. Write down the vector equation of the sphere. And the line, it looks like this, right? Okay, and then for part 2, determine whether the line is a tangent to the sphere, which means if I solve it, if I get one solution, that's a tangent, right? Before, I got two solutions. Sometimes you get one solution. In one of the later questions, you'll get no solutions, in which case it is not a tangent, right? That's the type of questions that you'll see. So let's do this one. Part one. Write down the vector equation of a sphere. So if I have center and that radius, that, so you go r minus the center. So if I do it as a column vector there, right, equal to 6. That's it, I believe. Let me just check that. Yeah, boom, done, right? So you can write it as a Cartesian, but that's, that's not what the question's asking for, right? Now, part 2, determine whether the line is at tangent, right? So guys, I'm going to do exactly the same thing as what I did before and see how many solutions I get for the quadratic. Yeah, the smarter people then, once you form a quadratic, if you use the determinant, right, which is a square root piece underneath square root, if you get a positive determinant, 2 solutions. If the determinant equals to 0, it's a tangent. Well, let's go there, right? Let's see what it looks like. So in this question, I got, so for my vector equation, so once again, express this, right? This guy here in terms of x, y, and z. So x equals to 1 plus 2 lambdas, y equals to 5 minus lambda, and z equals to 4 minus lambda. Okay, and I'm going to sub that into the vector equation. Now, it's interesting that they made you do this in vector form, because actually what's more useful, the Cartesian form, right? So I'm just going to write that as y plus 3 squared, z minus 4 squared equals to 36. That's more useful, because then I can just sub these guys here, right? Sub these guys here, sub them into there, right? And I get m1 plus, okay, this one's not as clean as the last question, right? Plus 5 minus lambda plus 3 squared plus 4 minus lambda minus 4 squared. Yeah, let's see what we get. We get 2 lambda minus 2. What's that? Is that 8? Jesus, okay. 8 minus lambda squared. 4's go away in this one, that's nice. That's just lambda squared. Yeah, let's expand everything. So you get 4 lambda squared minus 4 times 4 times 2, that's 8 lambda plus 4. 64 minus 16 lambda plus squared plus lambda squared. 6. Group your lambdas. There's like, what, 6 of them? Minus, is it 24 lambda? 64, that's 68. Minus that, is that 32, is it? Plus 32 equals 0. Quick, no, 36. Bad maths. Is it? Let's see. 68. By times, 4. 64. Is that right? My steroids. 68. Am I missing something? So, sorry. That plus that plus that. Because the answer's ever is 36. Is it 36? I don't think so. Is it? I need a calculator for this. I always thought 68 minus that was 32, not 36. Well, maybe the answer's wrong. 64 plus 4 minus 36. 32. Did I do something wrong? Let's say 64. 4. I'm going to write 32. Yeah, it literally doesn't matter in this question. So now you can divide everything, but let's just cut to the chase. Guys, find the expression for the discriminant. And I need it to equal to 0, because if it doesn't equal to 0, it is not a tangent, right? So the discriminant is b squared minus 4ac. And if you do that on your calculator, 24 squared minus 4 times 6 times 32, negative 192, which is less than 0. In fact, it's not even a tangent, right? So it doesn't even cut, doesn't cut the sphere at all. Therefore, not a tangent. Does that make sense? So this question here, very similar to the last one. The only difference is that I'm not actually finding the point. I'm just proving that there is no solution, right? In which case it's not a tangent. Yeah, boom, that's it, done. How's that so far? So the commonality here between this question and the last one is that whenever there's a vector equation and a sphere, make the vector equation in terms of x, y, z, sub it into the Cartesian form, solve the quadratic. In this case, not even solve, just determine that there is no solution, therefore not a tangent. So another one. So this one from Sydney Girls 2022. Once again, right, the theme is consistent. I have a sphere that's given to me. I have a vector equation given in column form. Find the points of intersection, boom, easy, right? Find A and B, and then find the angle, right? Just using the cos formula, I believe, right? Nothing too fancy about that, I believe. Yeah. Let's go. So part one, right? So express the line in terms of 1 plus 0, or just 1, no lambdas. Y equals to 2 plus 1 lambda. Z equals to 1 minus lambda, right? And I need to sub this guy, these ones, all into there, right? And I get x squared plus y squared plus z squared equals to 10. Expand. Please be a nice quadratic. Oh, that's right. Please be a nice quadratic. Plus that squared equals to 10. I got 2 lambda squares here. I got plus 2 lambdas. What's that, guys? Plus 5. No, plus 6. So minus 4. That's nice, isn't it? I think that's nice because dividing by 2, you get a nice quadratic. So I got plus 2 minus 1. Lambda is minus 2 and 1. Once you get lambda, sub it into the x, y, z to get the coordinates, right? So therefore, A. Now, does it say which one's A and which one's B? Let's see. Not really. So I'm just going to go A and B are. So lambda is minus 2. It's 1, 0, and 3. And 1, 3, 0. Yeah, piece of cake. Guys, that's 2 marks. Now, if this was a circle for part 2, and I have a line that goes through with 2 key points of intersection there, A and B, right? And the origin is there somewhere. They want me to find, oh, totally missed it. Let me zoom in. They need me to find the angle, right? I mean, that's a very easy vector question, right? Because I already have A and B, right? What was A and B, by the way? So why don't I go, I know that vector OA is the column vector for the coordinate of A, which was what? 1, 0, 3. Let me write that down. 1, 0, 3. And OB is a column vector for 1, 3, 0. Right, they want me to find the angle. So we know that now the formula that we're applying is cos theta equals to A dot B over magnitude of A, magnitude of B, right? Yeah, that's the formula that I want, where obviously this guy is A and this guy is B, right? Yeah, so I need the dot product and I need the magnitude. So let's just do it all in one hit. So cos theta is dot product, which is 1 times 1 plus 0 times 3 plus 3 times 0. That's pretty easy. That's just 1 over sort of 1 squared plus 0 squared. I'm just showing you all the working out, right? Plus root 1 squared times, plus rather 3 squared plus 0 squared. So then cos theta equals to 1's on top. That's a root 10, I think it's just 10, is it? Just 10, yeah. So therefore, theta or angle AOB equals to cos inverse of 1 on 10. Punch on the calculator. Nearest minute, 84 degrees and 16 minutes. Pretty easy, right? Like once you sort of get the hang of it, whenever someone sees a sphere question, a lot of them are like, oh, I don't know what to do. It's easy, right? If it's intersection question, that's how you do it. Angle there, it's a freebie. I mean, that's just introductory sort of vectors, right? Let's do one more question that involves spheres and equations of vector equations, right? Hopefully that's okay so far. I mean, the framework is pretty straightforward to follow. This one's from Hornsby Girls. Bit more involved, tiny bit. Consider the sphere, center, radius. Okay, get the way. Okay, they gave me this as well. All right, already in the form. Find P and Q, easy. Solve them. No, sub them in, solve them. A line parallel to L. What's L? Oh, that's this guy. Parallel to L is a tangent touching the sphere. Find the possible coordinates of R. Now that's a bit trickier, right? But not that tricky, right? Let's do part 1 and see where it takes us. So part 1, right? Sub that into so the sphere would be x minus 2 squared plus y plus 1 squared plus z squared equals to 29, right? Yeah. So let's sub it in. So I get lambda plus 1 minus 2 squared. I get lambda plus 1 squared plus 2 lambda plus 3 squared equals 29. Please be a nice quadratic when I expand. It looks like it, right? I think they've made up these. You just make up root 29, right? So let's say that's a lambda minus 1. So when I expand, it'll be that squared. 2 lambda plus 1. Lambda squared plus 2 lambda plus 1 plus 4 lambda squared plus 12 lambda plus 9. Okay, I get 6 lambda squares. That goes away, so I've got 12 lambdas here. I've got 11 minus 18. Oh, that's nice. Yeah, divide everything by 6. You get a nice factorizable quadratic, which is nice. Let me just check that just in case. Looks good. So factorize that, please. Ooh. Looks very good. Yeah. So that's minus 1, 0, lambda is 3. Ooh. Negative 3 and positive 1. Once you get lambda, sub it back in upstairs. Oops, just zooming out here. So therefore, is that A and B again? No, P and Q. P and Q are coordinates now. Lambda plus 1 lambda, so minus 2, minus 3, and 2 times negative 3 plus 3, so negative 3. Check that, yes, and Q and lambda plus 1 lambda, so 2, 1, and 5. Perfect. All right, that was fun. Yeah, pretty easy. 2 marks there. Guys, next question. Line parallel to that is touching the sphere. Okay, now draw yourself a sphere. Let's see, right? Draw yourself a sphere. Right now, I've got P and Q looking like that. This is P and this is Q, right? And the center of the sphere is there. Right, what's the center? C. 2, negative 1, 0. Okay. Now, this is telling me there's another line, right, which is tangential to the sphere and parallel to PQ, right? So, and whether they want me to find the coordinate of R, right? Yeah, that's basically touching it, right? Now, the way I'm going to do this is this is the new syllabus in a nutshell. So I keep calling it new. It was introduced in 2000. The new syllabus in a nutshell is this. They don't teach you the old topic of circle geometry. They give you questions like this that require you to use circle geometry. It makes no sense, right? Here I am going on ranting about this as well. There are so many parts of the syllabus where they used to teach you stuff that's useful. They no longer say you need to learn it. So teachers stop teaching it, but then they throw an exam question and they need it, right? So this is one of those examples where circle geometry says, right, that I'll use a green pen here, that if you have a line, right, that meets something at right angles or a tangent there at right angles, right, then, right, this side, this one here bisects the chord, right? That's what it says, right? If it's a right angle, it bisects the chord, right? I mean, it makes sense. And some people do, but the answers basically just say, just assume that it bisects it. It's like, okay, if you didn't do circle geometry, how do you know that it bisects it? Really, it does. So this is how we're going to do it. If I zoom into my diagram, right, over here. Now, I know a couple of things, right? I know that this point here, let's call that M, is the midpoint between PQ. I can find that coordinate quite easily. I've got P and I've got Q. I can find M as using the midpoint formula, right? Then what I can do, right, is I'm going to use blue. I can find, once I find the midpoint, I can find the vector of CM, right? Once I find the vector of CM, I say that the vector of CR is just an extension of CM, right? It's just blue but longer, right? The green vector that I want, right? It's just blue but longer, right? Let me delete these wings, don't need them. Yeah. So this is a game plan. I'm going to find black, the black point of M. I'm going to use it to find blue. Once I find blue, extend it, because I know what the radius is, right? Extend it to find R or CR. Once I find CR, I can then determine what R is, right? That's the game plan. So first step, find the coordinates of the midpoint of M, right? Where we know, what's the 2 points? Actually I got up here. So I just go find the midpoint. So it'd be like a triple midpoint formula, -2 plus 2 on 2, -3 plus 1 on 2, -3 plus 5 on 2. Now what's that, guys? 0 minus 1, 1. Yeah, got the midpoint. Right. Now, what I'm going to say is I've got the center and the midpoint now. Therefore, the vector CR, right, the blue one in this diagram, equals to R, so not CR, CM, right? CM is the blue vector in this diagram, will be M minus C. So it would just be 0 minus 2, so -2, -1 minus that, 0, 1 minus that, 1. Right? Once I got CM, I know, guys, right? Using my rules for parallel vectors, right? If CR right now equals to an extension, right, of CM. Yeah. What's the extension? If you think about it, right? I'm going to basically use the ratio of the magnitudes. If I take the ratio of blue and I extend it by a ratio of M, right? So go, so take a ratio of blue, take the ratio of green and go green on blue, that magnifies it from the blue vector to the green vector, right? So this is what I'm going to do. I know, right, just based on this diagram, that the magnitude of CR, which is the radius, it's √29. I know that. That's given in the question. Very quickly over here, find the magnitude of CM to be square root of -2 squared plus 0 squared plus 1 squared, which is what, √5. Therefore, the scalar here of lambda, right, is going to be √29 on √5, right? Because you divide by the blue and then magnify to the green, right? So therefore, my vector of CR, which is the one I really want, right, is just root. You can combine both roots on 5, multiply by CM, which is minus 2, 0, 1. Now, guys, once you get CR, what are they after? They're after the coordinate, right? The coordinate is always relative to the origin, right? Origin's over here somewhere, right? Yeah, if this is the origin, then I need basically, oh, wrong color. I need this guy, right? Totally missed it. I'm supposed to hit. Yeah, I need this guy. So how do I do that? I've got green. I've got orange. You see, so orange plus green is yellow. So then to get yellow, I just add it with orange, right? So I guess what I'm trying to say is therefore, right, OR as a vector, right, which is what the yellow is, equals to OC, right, which is the orange, plus CR, right? So let's finish this off, guys. Yeah, let's finish this off. So I got OC. OC is the center. What was the center? Got memory like a fish. 2, -1, 0. 2, -1, 0. And then plus this root 29 on 5. -2, 0, 1. Right? So, which is going to be 2 minus 2 lots of root 29 on 5. That is minus 1. And then 0 plus that. So that's just root 29 on 5. Yeah. So you can then conclude, therefore, the coordinate of R is 2 minus 2 root 29 on 5, -1, and root 29 on 5. Guys, how was that? Right? Just a bit trickier, just because it's a part 1 textbook, right? Part 2, they basically needed a bit of circle geometry, right? Don't like that, but there it is. Where we almost found the midpoint of PQ to find M, found the vector of M, extended it to CR, and then just use addition of vectors to find the coordinate of R. Guys, hopefully that was insightful, useful. If you haven't already done so, like the video, subscribe to the channel and tell your friends. See you guys later. Thank you.